And I think that's everything. There we go. All right. Hey, guys. Welcome to the latest episode of Ferris Makes Emulators again. Get sick of saying that, actually. I should start just like, we're streaming now. That should be enough. Anyway, yeah, hi, guys. Oh, hey, Jura. Ion1, Crazy92, Dana Collin. Good to see all y'all. Usual suspects. Is that Stewie? Is that how you say that? QRAM, good to see you again. Gizmo, good to see you as well. Cool stuff. Yeah, I'm actually starting to stream somewhat on time today. I'm only about 4 or 5 minutes late, which is actually miraculous, because usually I'm very bad at that. And I even forgot my OBS settings. Like I had OBS has something called profiles, which I thought was the different kind of scenes you have, which is like how you show different stuff on screen. And then also your streaming settings, like which services you're streaming to and that kind of stuff. Turns out, profiles only actually covers like which streaming services you're using, and settings like your audio and video output and recording settings. And it doesn't actually include the scenes. And so I streamed some Stepmania like a week ago and screwed up all my scenes. So if there's some alignments and stuff that's wrong, it's because I had to set it all up again. But yeah, now that's fixed. Now I understand that. So the point is, I thought I would be a lot later than I was, and I'm not. I'm really happy about that. So yeah, cool. Let's get started. Start working on some N64 stuff. Oh yeah, one more thing. Sorry guys for not streaming again in like 2 weeks. I know this sucks. Just been so busy lately, so I haven't been writing hardly any code anyway. But I really want to get back on this stuff. Like I said, I think I said before, ideally that like I want to do this like 3 times a week. So hopefully I can get to that kind of point, but we'll have to see. There's another couple of projects that I also want to start in parallel to this that I want to start streaming on. In particular, I started a new demo engine. If you guys are familiar with the demo scene, going to be working on some of that stuff. Also in Rust, so I do want to stream some of that, not all of it, because there is some like demo scene secrecy stuff that I think is really fun to kind of keep that way. And that project's not open source, so yeah, won't be doing all of that. But I do want to stream some of it just because I want to work on it. Might even do that later today after this broadcast. We'll see. Couple other things that I had in my head that have seemed to disappear. Yeah, not really sure. Yeah, no, that's what I was going to do. I was going to share what I was listening to. I have a playlist. I curate a lot of playlists on Spotify, or at least I used to. Not as much anymore, but I still do. In any case, I want to share the playlist I'm listening to today. It's called Ambient Electronica, and I quite like it. Bloop. Mena, good to see you. So there's a link. Some cool stuff in there. Also very demo scene inspired. In some cases, some demo scene tracks. So that's pretty cool. So yeah, I guess with that, that's everything I wanted to go over at first. Now we should just start going over pull requests and stuff, I guess. That's all my notes. Oh yeah, one cool thing that I wanted to show off before we got into that. At some point in the last, I think it was actually right after the last broadcast, like the Sunday after, Crazy92, he actually posted on YouTube. Let me pull that over here. Oh, Safari's not happy. Where did that window go? There it is. All right. What he actually did is he took, got some rendering errors. There we go. He took Rostendo, at least at the point that we had it then, which is, yeah, at least at the very beginning stage that we have it now. And he actually got it running on a Wii. So I'm going to share that link as well, because that was just really, really cool. So you guys should check that out. I mean, it basically just goes in through the menus, and then goes and plays that, and it executes instructions, and this is really sick. So congrats to actually getting that, work. Congrats to him for actually getting that to work, because I just thought that was so cool. And I really, I can't wait till we actually get some graphic stuff in there as well, that hopefully will be able to be supported. I mean, it might end up having to be like software rendering with some janky setup stuff. I don't really know anything about Wii dev, so correct me if I'm wrong, but anyway, that should be a lot more exciting later as well when we actually have visual stuff on screen, but that was just really cool. Matrix 404 asks if I'm just starting. Yes, I'm just starting. So I haven't actually written any code yet, just sharing some stuff. Yeah, and now that's everything that I wanted to go over. Oh yeah, actually, one more thing. Crazy's saying, yeah, I have no idea how well rendering will work. That sounds like a fun project, though. Yeah, there was one more thing that I just forgot already. Man, I'm good at this. Yeah, episode tags. Episode tags. I want to go over that. That was the only change that I've made off stream the last 2 weeks. Is that I believe it was Creelers on Twitter mentioned that I should start tagging the episodes on GitHub so that you can kind of see where we're at. Like if you're just watching the videos, you can go back into the commit history and go find the episodes. So I've gone ahead and done that. I don't think you can see it on the commit menu. I think you have to go into releases on GitHub. Yeah, here we have 6 releases up here. And what I've done is I've tagged the end of the episodes. So like at the end of episode 1, we've gotten this far, and that's cool. So I've gone back and I've added tags for all the commits at the end of all the episodes. And it's just easier for me to do that at the end instead of the beginning, I think, because there's a couple things I do off stream. I just don't want to make too many of these. But yeah, so I'll be doing that today as well. I'll tag the end of the episode. Yeah, that's pretty cool. I also added a note to that, a note for that in the README. Yeah, so that's cool. Want to follow along, a bit easier. Cool. So now I usually start with pull requests, so I'll go over that as well. I got 2, both from I still don't know how to say this name. Drivent. I'm not really sure, but he went over. He opened 2 pull requests, and also another issue that I want to go over in a sec. But these were just really small things. So one of them was backing store for the kseg 0 enabled bits. These were part of the, I believe, the config register. Yeah, right, config here of CP0. It had these bits that basically determined whether or not cache was enabled in the kernel segment 0. I don't want to go over into too much detail what that actually was, just because that's going to take me a while. I guess I could find it in the datasheet, but you guys can dig through other videos for that. The point is that basically there's these 3 bits, and certain combinations of those makes the cache enabled for this memory segment, and other combinations make it disabled. And I just stored that, in a backing store as a Boolean, whether or not it was enabled, and then I would just interpret the bits when you would set those. But then, of course, he pointed out that when you read those back, you also actually do want to store the individual bits so that you can read back the correct value. When you're going to give it back to the CPU. So yeah, so he just added the backing store bits for that, which I think was pretty good. Another thing that he did was he also added a comment here, which, can I expand that here, or do I have to go into his, go to view? Yeah, that'll work. Yeah, so here he also added a comment. So here he did the cache-enabled bits. We have the storage, it's just 3 booleans. And then we have this other state. So now what happens here is that this was the state that I had for it, which is whether or not it was enabled. And then what he added was these different enable bits. And what he foresaw then is that then, now that we have both, we actually have some state that could actually be inconsistent. And so what he's saying here is, should we extract this other state here where we actually set this second boolean to a method? And I agree with that. So what I'm going to do is I'm going to accept this, then I'm going to remove this boolean that I created and just have a isCacheEnabled method here that actually interprets the bits in the backing store. So that way we don't have the redundancy in storage, and also we have enough information to give the reader back the proper value if this register is actually read. So yeah, so I'll do that. Thanks for Drivent, I think is how you say that for that. Just going to go ahead and merge that now. And I'll go ahead and do that little fix as well. By the way, guys, I think I did mention that the kinds of pull requests that I want to accept are basically this. Like, I think this is a really good example of the kind of pull requests that I want to accept. Otherwise, I would rather people do like issues if they see things that are wrong. Just because I don't want to accept too much code that wasn't written on the stream. In this case, it's extremely localized and really small, and so it's helpful, and I really appreciate the pull requests. But I don't want anything bigger than this. That's kind of what I'm saying. So this was good. So now let's go ahead and pull that down and make those changes. to source, CPU, CPU0, reg config. And here I'll just remove my backing store, so we only have his. Gonna move a little fast here. And here is from reg config. Yeah, we'll just do this here. Let's do kseg 0 dash enables. Self turn a bool. And it's just gonna be this actually. Or it's going to be a little different than this, actually, just because of the way this is done here. So it's going to be self.kseg 0 cache enabled bits. So actually, we'll just basically do. And then we want this one to actually be false, and this one to actually be false. Or no, it's not equal. So cache enabled if it's not that. We could do this as well. And then these we want to be like this. Crazy. Doubt you can define a method trade impl. Yeah, okay. That was me going too fast and not reading. You're correct. It's I need to do this. Impl reg config. Boom. Ernest, good afternoon. Good to see you, man. Yeah, if you guys didn't tell me that, the compiler would have, so. But I think that's correct. The bits are not 0, 1, 0. Yeah, that looks good to me. Ernest, James Bond episode? Not quite sure I understand. Oop. There goes my phone. Probably Twitter. Cool, so that works. Don't need to worry about that. Oh yeah, episode 7, of course. 007. Of course. Cool. So I'll go ahead and do this. Done int. Cool. Push that. PTA Nugget. GoldenEye by the end of the stream, you can do it. You know, this stream will be long. Yeah, this would be quite the long stream. And there would be a lot of like me sleeping and doing other work and like okay, cool. So that was that pull request. He opened another one, the same guy, slightly less ambiguous panic messages. And I believe the gist of this one was basically just like formatting when it was saying like unrecognized registers and also unrecognized instructions. Just so that we pull a little bit better data out of that, yeah, to help us debug these kind of things. So I'll merge that. Cool. And we'll go ahead and pull that down. And looking good. And you can see that right here now as well. We get the unrecognized instruction here, and now we have a guaranteed number of bits, or yeah, number of values here. So you see all 32 bits of the instruction here, I believe. Yep. And then here as well, we also see the binary representation of the op. In this case, it's all zeros because this was a special op, as we saw in the end of the last episode. It's going to be a jump always. We're going to have to start decoding that. So that should be pretty cool. Move away 00. Have fun streaming for the next week straight, at least. Yeah. That's if I did the golden, I think. Yeah, that would take a while. In fact, I think by the time we get a game like that running, there's going to be so many changes we'll have to make. Like, I've actually already been thinking about how we're going to handle the case that we're going to run into really soon, where we have simultaneous execution on the CPU of code on the CPU and also on the RSP. And I might just be cheeky at first and just have both run in lockstep, which is wrong for a lot of reasons. But I think that it would actually be okay to do for something starting out. I mean, to correctly emulate it with proper speeds and everything, we need to actually emulate how many cycles each instruction takes on both of those, and then they both run at slightly different clock rates, so we're going to have to fix that, and then there's going to be arbitration between them, and lots of like nasty things to get that really correct, but I think actually just running them at the same speed is actually going to be correct enough to get something running first, and that's kind of my goal with this, is I want to just I do actually want to cut those kind of corners until we get how can I explain where I'm coming from? Because I know so little about this system, and I only really know what I've discovered from doing these streams, I have this really sort of blurry vision of how the emulator should work, and I kind of want to implement it with that blurry vision to try and get as much of the high level details correct as possible before I go in more detail and start fixing those smaller things that I think are going to matter a little bit less. So yeah, so that's where I'm coming from on that. I mean, I know that that means I'm basically making a crappier emulator at first, but if it gets us to an emulator at all, I'm going to be pretty happy. So that's just the practical side of actually doing this work. Yeah, so I wanted to also go over this issue here. Oh no, sorry, that other pull request actually closed that issue. It looks like, or maybe that was the case I go on. So I think actually I didn't want to close this. Yeah. Just in general, the gist of this issue is that things like those bits that we saw earlier in that other pull request, there's a couple other fields in the config register that we're not going to be able to return the correct values as soon as it's read. And I kind of put that off on purpose, understanding that we're not actually reading those registers yet, so I wasn't kind of worrying about that yet. And I just figured we'd fix all that stuff when we actually read the registers, but it's still nice to keep this issue open so I can be extra conscious of it as we move forward. So, wanted to reopen that. Daniel Collins should be fine to start that way? Yeah, I think so too. Because I think the different, the CPU I think runs at 100 megahertz and then the RSP runs at 60. And I have a feeling that there weren't going to be games that relied on cycle accurate timing between the two. Could be wrong, but again, for high level emulation, that should be okay. Jura1 says, what's your goal for tonight's stream? I don't really have one. I think in general that's kind of been the case. I don't really have a goal for when I'm going to stop or anything. I'm just going to go for a few hours and then stop, I think. Anyway, we're still working through the PIFF, so I guess we'll work on that. And I think, actually, the reason why I'm also bringing up the RSP execution and the parallel stuff is because I have a feeling we'll get to that today. I happen to know that, or in the last stream we saw, Thresher HT, hey again. In the last stream, we did get to a point in the PIFF where it copied a bunch of code into the RSP's instruction memory. So I have a feeling we'll actually start execution there today as well. In fact, I believe the jump we're running into now in the PIFF will actually then jump over the part of the ROM that it copied. Not actually sure though. We'll find out when we actually emulate it. So yeah, so the point is I don't really have a goal. I'm just gonna make progress. That's the goal, I guess. Yeah, that's what I forgot to open. I forgot to open the online disassembler. But we actually don't really have to worry about that right now. Let's just start working on implementing this instruction. TJS says, good to see you again, by the way. The jump will jump to phase 2 of IPL ROM that executes from the RSP, I think. And he says the games begin. Yeah, this is where this is where we get from, I guess, the point where we've just been like the emulation so far, I think, has been really trivial as far as emulators go. And now that we're starting to actually have hardware interacting with each other, things happening in parallel, now things will start getting kind of serious. But I think that'll be really fun. It's just that probably going to take me a while to get my head around some of this stuff. Actually, TJS, if you could enlighten us. So it's saying it will jump to phase 2. I'm not entirely sure how that makes any sense, actually. Like, because here's what I don't quite understand yet. It's that the CPU has been turned on and it's been executing code. And what has the RSP actually been doing? Like, is it sitting there idle, and does it like wait for like you just fire off tasks or something? So like when we jump, do we actually like change the instruction pointer? Like, it doesn't make any sense to me that we would just start executing. Like a jump would actually make it execute from the RSP. So I'm not really sure what that means. Maybe I'll just have to dig and we'll find that out, but. FPGA Naga says the CPU is using RSP IMEM and DMEM as scratch memory because it hasn't set up the RD RAM control yet. Well, that's actually pretty interesting. Then it says it's just waiting for a flag to be set in the RSP coprocessor before it starts executing. TJS also says the RSP doesn't actually execute the checksum though, which is, I guess, the security stuff that's going to be running through with the ROM. The VR4300 will still execute the IPL phase 2, it's just that it will be executing it straight out of the RSP's cache. Oh, okay. I gotcha. So the RSP isn't, yeah, okay, that's what you're saying. The RSP isn't actually executing it. He was talking about different like phases of the IPL. I guess this is all labeled somewhere. People have probably torn this thing apart. Something fierce, but I haven't looked into that. But yeah, I'm guessing that's just like, because we had this loop here. It was just moving memory into that, into RSP's IMO. But yeah, that was actually fairly interesting. Alpha 8 all not using Emacs lame. I am using Emacs. Yeah, I didn't realize that you'd have to set up the RD RAM controller to actually start using RAM, so that's actually fairly interesting. I guess we'll learn that about the system as well. It's actually really cool that a lot of guys who are a lot more knowledgeable than me have actually been watching this and contributing in the chat and also in person as well. By the way, quick shout out to N64Dev, the IRC channel on FNet, because there's a lot of cool guys in there. Including basically everyone who tells me that I'm wrong on the stream. You guys are interested in N64 or just general fun chats with some guys that know a lot about hardware. N64 Dev is pretty cool. Yeah, so I guess now we actually look into implementing this instruction. Implementing this instruction. There we go. Speaking. Okay. Let me pull up my disassembly as well again. Again, I'm using this online disassembler just because it's very easy to set up. Definitely not the best disassembler around, but it's quite good. Sadly, I only know about consumer computer hardware. I know nothing about proprietary hardware. Well, it's still hardware, right? And so a lot of it's actually going to be somewhat similar. Pull up my Xfiend as well. Actually open up that ROM. Looks like my temporary flatmates just got home, so if I get an interruption, sorry about that. Elfade all N64 emulator and Rust. I guess we're hoping Rust catches up to speed, catches up in speed to C++ before the emulator is done. Heh. I think that that's not going to be much of a problem. So just copy some of these from bytes. That would be good enough. Also need to change the platform to MIPS 4300. And then we need to set big and in. Actually get proper disassembly. So we had that. Let's put the here. COC. Did I get that far? I did not get that far at all. Oh no, BFC, sorry. CC. Should be here, right? Yeah. Here it is. JRT3. So yeah, JR I believe was jumped to a value in a register. It's using T3 in this case. Oh, this interface is not the greatest, but it'll do. JRT3. Guys in the chat are talking about speed and Rust, and sorry, Elfade all, I blocked links in the chat. Only I can post links. Basically, they're talking about how basically Rust is not really noticeably slower anywhere than C++ with common benchmarks. Elfade all is apparently trying to link some benchmarks. Would be somewhat interesting to see those, but I'm going to be naturally skeptical actually about the quality of the benchmarks. Man, never click links in Twitch. Yeah, again, I blocked links in the chat, so we shouldn't have to worry about clicking those links. Yeah, so we're going to look at this. Was it JR? Yeah, JR instruction. Jump register. Here we go. I'm getting distracted, which is quite typical. Yeah, so for this instruction, the encoding, it looks like there's a bunch of these special instructions. I mean, if we go up here, we also see more of these. And so it looks like this first, normally what we would consider the opcode is just all zeros. And then these last 6 bits, or first 6 bits, depending on how you order your bits, look like they will actually define the specific opcode as well. So we're going to need to actually model that as well. Is it here that I had opcode? Yeah, it was. If at all, I am actually curious to see those benchmarks. Actually, if you can message me the link, I can look and post it. Because I am actually curious. Even though the discussion isn't quite that relevant for this stream, I still, if the benchmarks are interesting, I'd like to share. So here we're going to do special. Fix all my alignments. And then in instruction, I want to model this. Or, yeah, no, we're actually fine here. But I want to add a method here. I'm not sure if I still want these inlines, but I'll just keep using them anyway. That ain't be a problem. But here I want to do a... Alpha et al. Is asking if I'm just emulating the CPU or RCP and friends too. I plan to emulate everything. It's just that we're only like 6 episodes into this, so I'd say we've been working on this for like something below 15 hours. So we just haven't gotten very far. And it's naturally slower as well, just because I'm streaming everything, so the process is slower because of that. Colin, there's also the case that the Rust compiler can use LLVM better in some cases than it does today. I'm not worried about that, to be honest. I'm not worried about the speed and stuff either. I mean, I like talking about it. I've also heard from TJS in particular that GCC actually does a lot better in terms of optimization than LLVM. And generally it's because they like LLVM won't allow themselves to do anything hacky, right? Whereas GCC has tons of like, very specific use case hacks or platform specific hacks. Which, while they're hacks, they also make the code faster, so you could argue that they're not hacks, actually. So, but again, I don't think that this stuff is going to matter much, and it's really not going to matter much for us for a long time. Fidel was also saying, yeah, it's in any case not a big deal because the performance difference is only marginal. Again, I still think it's interesting discussion, so I don't mind it being brought up. But yeah, in general, it's. I think we're all sensible systems guys here. So. Not going to worry about it too much. So I want to do special op in this case. And I'm not sure what I'm going to return here, because I would like to name these. So I think what I'll actually do is pull up opcode here again. And I might do special as well. I think I'll do that. Do special opcode. Start. Put everything. Basically gonna copy this. For this, it's gonna be special op this time. And here we don't do the shift. Whoops. Always hit that dashboard hotkey. Also, I'm gonna fix that. Organized. Here. Yeah, that's actually nice that we still provide the whole value and then the up here. Cool. So now I actually start modeling these. I could put it in its own file. I don't much care. In any case, I want to scroll down here. I'll just copy more of this. Save me some typing. I'm really not that dogmatic about putting all their types in their own modules. That's one of those things from OOP where I'm just like, you know, if you're really dogmatic about that, I think it actually hurts some things. Especially because sometimes you do actually get highly cohesive classes. Cry's is asking, by the way, what's enum from primitive for? I believe that was for this decoding here. It gives us this from U32 function here. That will either give us the opcode if it worked, or it gives us a result, I believe. Might have been an option, I can't remember. I went over this in episode 3 or 4, I think, where I picked a library to use that. But anyway, we need to decorate this just so we get this method. And then I don't have to do the decoding myself. That's all it was. So we have JR. These are ones. So yeah, so that should be it for actually finding the special op. I'll run it again just to make sure everything compiles. I do this stuff a lot of times. I'll just write a bunch of code and then, even if I haven't changed anything operationally, I'll still make sure it compiles. Non-exhaustive patterns, special not covered. Yep, that's actually true. This is actually cool that it actually gave us crap about that. Now it's telling me that we didn't cover all the opcodes, which is correct. So in this case, we have special. And here, what we're going to do in that case is we're going to match inster.specialOp. And then now this is going to make us also cover special opcode. Oh, I guess we pulled those in, didn't we? We did. Opcode star. We'll also use. I don't think these are going to conflict. We'll pull both of these in. Should be okay. Yeah. I just want to see this. Boom. Cool. So now we've decoded it properly. That was quite nice. Now we'll actually implement it. Because JR... Because I see, by the way, after blocks, you don't need comma and match statements. He's telling me I can get rid of all these. And I think I will do that. I guess you only need them if you actually have a single expression. Probably to delimit the expression. There's going to be cases where that might be ambiguous. Cool, that's a bit nice. Sure, implement me. Is there a JRRA1 or is it JRRA? Is JRRA an actual instruction or is it JR? I think that'd be fun. Or if RA is one of the register names. Get distracted again. Oh, whoa, wait a minute. This just told me that I did actually need a comma. Is it? Oh, that's because here I need it. I think because I didn't put this in a block. It's because this is actually an expression. I could make the form match if I do this. Then I should be okay. Yeah. Yeah, it is JRI. Fortunately, JRI was taken on Twitch. I don't know if you actually call yourself Jura either, but I heard Mike Ryan saying that. I just started saying it. Easier than saying JRI. TJS today, I learned that's where you got that from. That's actually pretty cool. Yeah. Notice TJS says today I learned a lot, which is good because you gotta keep learning in life. Yeah. Program unconditionally jumps the address contained in general purpose register RS with the delay of one instruction. So I believe that's telling me that it will jump and run the instruction delay slot. Since instructions must be word aligned, a jump register instruction must specify a target register RS which contains an address whose low order bits are 0. If these low order bits are not 0, an address exception will occur when the jump target instruction is fetched. Yeah, since we're not really worrying about exceptions too much right now, I'm going to basically ignore that. The thing is, when you're implementing stuff like exceptions or cycle counting, I find in general it's best to just defer, like do all of it up front or defer all of it. Like don't just do it half-assed or halfway, because what's going to happen is you're going to get into a situation where you're going to go through and try and fill everything out, and it's going to be hard to tell where you have and haven't implemented stuff. And in general, I don't think we're going to run into any things that should have caused exceptions for a while anyway. Generally, well-behaved code shouldn't really be using exceptions as a general execution flow mechanism. Except for, of course, the fact that reset was an exception that we're actually executing in, but we'll never return from that, so I think it's going to be okay. Or at least I think we'll never return from that. Those are the kind of cases where it just kind of helps to have low-level systems knowledge in general when writing an emulator. It's also, I think, the case where you can learn a lot about that stuff from writing an emulator, so it might be like a chicken and egg problem, but cool stuff. Physics 404, how will you progress on emulator later when you need to get going on actually executing game properly and you're probably not allowed to stream game assembly code live? I have a huge collection from this guy called Turtle. It's actually his collection that has a ton of public domain ROMs, right? And so I plan to use those to see if we can get as far as possible. Because the thing is, if, for instance, the Zelda game that I showed in the first one, I showed a tiny bit of it, not enough to consider it broadcasting, I think. In that case, for instance, I'm legally allowed to have that ROM because I also have the game. That's my backup copy. So I'm allowed to have it and use it for this use, I think. But yeah, I can't necessarily broadcast that. So I don't think I'll be able to display a lot of that work. I think also at some point, but yeah, we'll do the public domain ROM stuff. And also, there's a bunch of assembler test ROMs floating around the internet. I can't remember the guy that had that repo. I want to find it, actually. TJS and Jura are going to know, though. That collection of test ROMs that someone made. And I might have linked it in the Rostendo stuff. Anyway, I want to be using stuff like that as well, so I think we're going to be okay. Meta, do you think the FBI is watching you? I don't think the FBI is watching me. I don't think that even if I did break copyright law, that I think there would necessarily be consequences in this case. But I mean, in general, it's best not to break the law, right? To just not do stuff that you could get in trouble for. So I mean, I am trying really hard with this stream as well to operate, within what I'm legally allowed to do. At least for my understanding. But yeah, I think we have plenty of resources where we can get really far without ever having to dig too far into that stuff. The other thing is that once we get to a certain point in the emulator, there's probably some of that stuff. There's going to be parts of it where I'm just probably not going to stream everything. And mostly that comes down to, if I want to make this a production quality emulator, how much of that stuff is actually going to be fairly interesting. And is it going to be worth like keeping up the diligence that it actually kind of takes to stream everything like this? So, you know, when we're at that level, I think that I won't be streaming everything anyway. But I still want to stream some stuff, like, oh, I found this really interesting bug, and here's how I fixed it. So that would be cool. Yeah, TJS also raised a good point. I was able to write an N64 emulator that booted basic ROMs only by looking at the few instructions before the crash. And so what I think he means is that like he would try a ROM and it would crash because his emulator wasn't correct, and then he would just look at the few instructions before that. And that's relevant because then you're not, you know, effectively distributing the whole ROM, right? But again, I think I'll just stay away from that stuff as much as possible. Should be okay. The other thing too is that, and I've talked to this with a couple guys off stream as well, that you know, copyright law, and in particular when you're doing reverse engineering stuff, is actually quite complex. And you know, what you are not allowed to do, from my experience in just doing this stuff, sometimes falls into gray areas. And so one of the things that's actually been really interesting for doing this project has not only been, you know, making an emulator and learning about this really cool hardware and everything, but also you know, learning more of that legal aspect and learning, you know, what are my rights and what can I do and what can I not do when I'm trying to broadcast. I mean, again, I don't think in this case it's going to be particularly relevant because I don't think I'm really causing economic damage in any sense anyway, you know, for a system that's not necessarily commercially relevant. But it's a really cool exercise in learning, like, you know, where are the limits? What can I do? What can't I do? And so I've actually had a lot of fun learning that side of things as well. But I definitely plan to do more reverse engineering in the future as well. So I would really like to know, yeah, where the boundaries are. So that's been fun. Meta says the legal aspect is irrelevant. Whoever has more lawyers wins anyways. If it ever becomes a case in the first place. I do kind of agree with you in whoever has more lawyers wins anyways. I do think the legal system in the United States tends to favor the side with means, and I think that that's somewhat dark, but I don't really know of a system that I could design that would work better. So anyway, that's an entirely different discussion than actually writing an emulator. But I also find that stuff interesting as well, just on a personal level. Anyway, back to this instruction. All we actually have to do is load the value from this register RS. We're going to raise an exception if that contains something where the lower order bits are not 0, lower to 2 bits. To make it 4 by line, we're going to ignore the exception for now. Then we're actually going to jump, and we're also going to execute the instruction delay slot. I'm going to end up doing some, you know, basically copying of code here again, I think, and then refactor after, just for handling the delay slot. But I think this is actually all it took, because we are always going to take it. I'm also actually like a side note on the legal system. I wonder if because if never mind, I'm just thinking on a tangent. Never mind. Yeah, I'll just copy this code for now and take out the parts I need. Take our old PC, which is, I believe, the one before we've incremented anything, because, or actually, do we increment before that? Run instruction. Yeah, we read it and then increment and then execute. So this is actually the one, old PC in this case, actually points to the instruction delay slot. You know what? I'm actually going to refactor that underneath. I call it old PC, but I really want to call it delay slot PC. And it's basically saying that I won't get targeted about this stuff. And I don't think I'm doing anything particularly damaging with this work. Literally, my intentions are to learn about this awesome hardware and share the process of writing an emulator, which I find interesting because it has to do with hardware. And I think I'm accomplishing that. I'm also not distributing ROMs. And I want to make that very clear. Delay slot PC. Oops. Yeah, just the same one as last time. Good. So here, we don't need to do any of this. Effect all, yeah. There's probably going to be some refactoring I do where I like try to share some of this code, where if we know we're going to do a delay slot thing, where, yeah, I'm really not sure how that's going to work yet. How that code's going to look. I think I just need to implement more instructions before I start thinking about that. Like premature abstraction, I think is just as bad as premature optimization. And just as tempting. Yeah, so all we actually have to do is just load this with stuff.read reg general purpose register instructions rs. Done. I think that's it. Except sign extend. Although general purpose registers were 32 or 64-bit. I believe I had them as 32. TJS might need to help me out on this one. Do I need to sign extend this or not? I don't think I need to do that. Is it here that I did that? Or my GPRs? Okay, so I do actually have these as 64-bit value, so I don't think I need to sign extend here. I think it's just going to be a move. I think. We break GPR. Yeah, should be okay to just copy the value. TJS, no, just those are, sir, you're correct. That makes sense. Those are all the little gotchas you always have to worry about, but looks like we're okay. And away we go. All right, so now we got another unrecognized physical address. So first of all, a couple things. The first thing we notice here is if we look at our little disassembly, we don't need to actually see the operands. I think we're okay there. We see we had the special instruction, which is what we ran there. And that looks like it jumped us to a 4001000, which, if I remember correctly, in our memory map, which is out here, that was our IMEM. Also, I'm going to fix this alignment really quick. Yeah. Interestingly enough, though, it actually runs out of A400. And, oh yeah, that's because it's running through that kernel segment, probably. When we have IMEM now. Yeah, looks like we're executing right out of that, which is really cool. Yeah, I believe the reason why this is A is because this puts us in that same memory region that we were in here when we were executing the boot ROM that basically said this wasn't going to be cached or used as TLB. And that's good. So in that case, we had an LUI and an LW. Now the problem, one of the funny things here is that I can't really go in and look at the disassembly now. because it's been moved to this address. So I would need to actually like start dumping addresses from here. I'm not entirely sure how I want to handle that as well. I could like this is the case where you actually kind of want to start having a debugger instead of having it just like panic here, have it break, and be able to actually look at some disassembly from there. But actually, just because these instructions are ones that we've done before, it's actually probably correct that it went to try to read this address, load word from this address. It's probably just the case that we haven't modeled this yet. I'm guessing that's going to be it. So what I'm actually going to do is just look that up in our memory map first, and we'll go from there. Where's the memory map again? I'm going to display these. Okay. So where were we again? By the way, just realized you guys couldn't see that. My face is in the way. I was just saying you could use GDB. Yeah, I could hook up to that. At least I don't have to do a lot of the interface stuff. But I do actually want to do like a generalized debugger anyway. And I also want to, I've said this many times, but I want to integrate with ProDBG at least. Just Daniel Collins' project. L8all should have used Haskell. Then perf would have been really fun. Or dump it to disk use on or something again. That would get us there quicker. I think we'll be okay. Yeah, so I just want to look at what this address here was actually pointing at. 1SC. C0 7FC. Okay, looks like it's the PIFF RAM. Looks like it's right at the beginning of that. Or, yeah. 07C0, so PIFF RAM. That talked about anywhere else. So I'm assuming that that's just going to be some RAM that the PIFF can also see. I don't really know much about that stuff, though. More like the last 32. Yeah, that's correct. The very last byte in PIFF RAM. So I'm gonna assume, or I'm assuming that this is just RAM, but I have a feeling there might be more stuff to this. So I think I want to actually search this repo thing to see if I can find anything about the PIFF. Got some libn64 stuff in here. It's not actually what I'm looking for. Oh, except I did actually find a little bit of code here in libn64. Hardware interhook, it says initialize the PIFF by actually storing a word to the same address. Interesting. So I wonder if this address is being used to communicate with the PIFF somehow. Looks like this document will look over some of this stuff. PIFF RAM start plus 3C. That's where we are, right? C0 plus 2C. Yeah. Okay, so that's just saying what that code that we just saw was doing. I am going to do something in the memory map, though, just so we have this on. Get this set up right. C0. Yeah, so here we have. Nice. Not Mike Ryan is saying PIFF RAM is a block of RAM physically located on the PIFF. I wonder who not Mike Ryan is. Okay. Also, good to see you, by the way. It's used as a shared mem scratch space for talking between the rest of the system and the PIFF. That would make sense. So I'm guessing there's going to be some like effectively hardware mapped registers in the context of the PIFF that we're going to be reading and writing through this scratch memory. VGA Nugget, the boot code is doing something else here. When games boot, they do magic. They do that magic right to the command slot to start lockout chip activities. I'm not sure what that means yet. What if C0? C0. This is a small amount of memory. Looks like that's the right size. 64 bytes. C0 to FF. Now, Mike Ryan, later the system pulls the state of the controllers via the PIFF. PIFF is peripheral interface, controllers are peripherals. Yeah, that makes sense. That makes sense. Shout out to Titanic for showing us how to boot N64 homebrew without crashing instantly. Not Mike Ryan, it's a small amount of memory because it's physical SRAM on this tiny chip. Fully half the chip's total SRAM. That makes sense. Still, 128 bytes of memory is not a lot either. But I guess you don't need much if you're just going to basically be producing random streams of bits and pulling a couple lines high and low. Daniel Collins says, dead stream? I don't think I've dropped any frames. Yeah, stream looks strong on my end. Sorry about that. Yeah, Crysis TJS have a stable stream. Actually, I need to go use the restroom though, so I'm going to take a little break anyway. By the way, not Mike Ryan, I don't have links show up in the chat. So if you're linking to some PIFF docs and stuff, that'd be awesome. If you can message it to me, that might be good. Yeah, I'll be right back in like 5 minutes. Cool, we're back, and boy do I have a pretty pic to show you guys. So, not Mike Ryan sent me this. I'll send the link here. Man says you guys are way too paranoid. Hey, you just can't trust links. I think that's the only thing I blocked, though. It's just links. But what he sent me is this picture right here, which I guess is from siliconprawn.com, which is a guy by the name of, is it Mike McMaster? I met him a couple times. No, sorry, not Mike. John McMaster, of course. I met him a couple times. He actually runs a reverse engineering meetup here in the Bay that I go to, or that I've been to once. I would like to go to it more. And he basically just like throws acid on silicon and just, he's really good at breaking stuff. And he gets awesome die shots like this. So I'm guessing what we're looking at here is, yeah, this is the link that, again, not Mike Ryan sent me. And again, what we're looking at here is actual die shot of the PIFF. So what he was saying, he told me which part of this is actually the memory. He said that this is the SRAM here. This top grid pattern in the middle of the chip. I believe this is what he was referring to here. He's saying that yeah, 32 words of 4-bit nibbles, because it's a 4-bit CPU. Actually, by the way, they have an awesome, Mike and John and another guy did this awesome video about basically reverse engineering the PIFF. Actually, Mike, if you could send me the link to that, I also want to share that, so I don't have to go look it up right now. He said if you zoom in on this, you can actually see individual bits. Oh, this is super high res. I did not notice that. Oh, I love this stuff. Okay, way up here. Here we go. Yeah, I believe this is the right place. Yeah, here we go. Oh, this is so cool. Yeah, so this is basically that piece of memory that we're looking at. And one of these halves, I'm guessing, is the one that we're actually communicating with, and the one that we're about to load a word from, which is pretty sick. Then we can start seeing individual bits, which is going to be these. As you can see, they're organized in groups of 4. I'm guessing these are going to be nibbles. Oh, that's so cool to see. Awesome. So, yeah, thanks, Mike, for sharing that. And here is... Oh, and he just told me that the other guy is Marshall H, so I didn't actually realize that that's who that was. Guy behind the 64 drive and just, in general, a hardware badass. Yeah, the link I just shared is the actual video where Mike and John and Marshall actually go and reverse engineer this stuff, which is really cool. So go and check that out. It's an awesome way to spend a couple hours. So that's really cool. But yeah, so this was the PIFF then. This is we're gonna work on emulating this. I'm guessing we'll have to, because this code is probably going to read a value from there. I'm guessing we're gonna have to emulate some parts of the PIFF as well, so that it actually reads the right value back. But sick. Fix my typo. So, I'm not entirely sure how I want to model this yet. Not entirely sure. I might as well just make a PIFF thing here. Yeah, I'm going to do that. Then in that here. Yeah, call in virtual6502.org has some cool scans as well if anyone's interested. Agreed. Also cool stuff on there. If you're into silicon that you can actually manage to look at all at once. I think everyone in this software should get into at least learning about a lot of hardware. Hardware's cool. Yeah, so I wanted to, in the case of the, I believe it was N64 in here, I have, no, it's Interconnect, of course. I had a PIFF from here, and I'm actually going to move that onto the PIFF. Even though it's technically not the ROM that executes within the PIFF, and I might want to rename this to actually change, like to distinguish that. You know, they also have a transistor level emulation of 6002, which is pretty cool. That's actually what I saw from them first, and it is sick because you can click through a cycle like progressing and just see all the different transistors flip. It's pretty nuts. That would actually be, if our computers are fast enough, that would actually be the way that you would want to have an emulator. But yeah, run into other issues at that point as well. In any case, obstruct. I'm going to call this boot ROM in this context, because it's really the system boot ROM. I still think that name is somewhat ambiguous in this context, though. But I'll stick with it. I think I'll go with that. And then we have the RAM, which I'll model as U8, because I think it'll be okay. Because I don't want to do particularly low level emulation on the PIFF. That doesn't make that much sense to me. In any case, move the PIFF ROM from here. Oh wait, I already started PI, which is peripheral interface. Okay, maybe I should have called that something else. But actually, so I'll move this stuff to there. Yeah. Peripheral interface. FPGA Nugget is saying that PIFF is not PI. More confusingly, PIFF handles the SI, the serial stuff like EEPROMs and controllers. Okay. And maybe I will make something specifically for the PIFF then. But I definitely thought that's what that was. It's probably just a really convoluted piece of hardware. Oops, I literally just made that PIFF.ROM. The PI is the cartridge interface for game ROMs and such, says FPGA Nugget. Good to know. Obstruct PIFF. You're saying you only have a single byte of RAM, though, yeah. That was a typing mistake, not a logic mistake, which is very common for me to do. Yeah, I'll just call this the PIFF. We'll be all right. Cool. Yeah, and I don't think we can. Yeah. We also don't need RAM size here because that we can get that from the memory map. In our memory map, go ahead and make that public. The reason I'm not just making all this public is just because I don't have to. Might do that later for consistency, but until I have a technical reason to, I think I'm going to hold off. And then PIFF. I might bubble this up and make this called boot ROM for everything. Cool. Mm-hmm. And there'll be more stuff in there, like changing this code. I'll get to that in a sec. Do the same thing here. That was right, yeah. Thanks again, Krause, for finding more of my typing errors. I said this before, but it's like having a compiler made of 50 people in addition to my actual compiler that runs in real time while I change the code. Okay. Was I correct that you couldn't cast here? Good, we're fine. We want to, in Interconnect, actually read the values here. Yeah, so in this case, we'll make the function read boot ROM word. Debukalev. I think I'm saying that right. First time catching it live. I've enjoyed the previous episodes. Awesome. Thank you. Glad to hear it. We'll take, since we're just reading, I think it'll be okay if we make that mutable. Take the adder, which technically would need to be like a U32. I could make it a U8 just because of the range of values. But I'll make it a U32. So you don't have to do as many casts. It's really not going to matter. Cool. So this is actually all we have to do for the boot ROM. Oh yeah, we actually have to do the big Indian stuff as well. Not a problem. Excuse me. Boot ROM. Let's remove the word from here. Don't really need it. It's like Buckaloo. This is so close to pronounced like Buckaloo. I assumed it was like Polish or something. Lived in Europe too long. Yeah, because we're going to need to read those. I don't think we'll need to write those as we've done here. Don't need to worry about that. So the other thing is that I believe I need to pull in that big Indian stuff. I think actually that was the only place that this was used here. In byte order, is that used anywhere? Oh yeah, that's of course to bring in the read trait. So we can move that out of there, pull it into here. Cool. Also, don't think we need to use super here. Let's do that. And of course, we don't have offset because I called this adder here. Cool. So now this means we've effectively moved the boot ROM because it ran again. The only way that could have happened is if this worked. So that was a nice little easy refactor. I'm actually going to reorder a couple things. Put the PIFF above the RSP just because you touch it first. Oops. By the way, thank you to all 43 of you, apparently, who are watching this. That's awesome. Yeah, maybe that's what I'm looking for. Just do a little bit of cleanup here. I think it's a bit nicer. Yeah. Cool. So we're actually going to start emulating that RAM. The first thing I'm going to do is I'm actually just going to basically copy this. I'm not going to worry about what that value is actually supposed to contain yet. I'll do that in a sec. But then we need to in memory map. PIFF RAM 32. So now we can decode that properly, and then the interconnect is going to need to use it. Actually, compiler will tell us where that is. Except I called that boot RAM. And then, yeah, now we have these non-exhaustive patterns. So need to write the RAM. Oh, and I called this boot RAM as well. That's funny. Yeah, we're good. Assuming this is just going to be correct. We'll find out. I have course value. And we're not returning anything in this case. Good. And now we got another special opcode. Cool, cool. So I'm not entirely sure what this code is doing. I'm just going to implement that special opcode first, and we'll see what happens. Yeah. I'm actually going to, by the way, just so you guys can see that. Not covered by my face. This is the op that we got. Special op here. I'm actually just going to dig the data sheet a little bit to find it instead of just looking at disassembly. Maybe that wasn't such a good idea. I just think it'll be easier to dig this out than it will be to dig out a disassembly of this part. There's a couple of these. Just looking at 1-0. Almost. There we go. SRL, shift right logical. Cool. Cool. So let's go ahead and implement that instruction. So much jumping back and forth on stuff, but we're definitely making progress here. And that's cool. Yeah. Opcode. JR. I'm going to add SRL. Cool. I find it entertaining that I drink 3 different beverages when I'm streaming. Okay. Don't need those because it's a block. Yes, this is giving us the target RD. Constants of general purpose register RT are shifted right by SA bits. That makes sense. Inserting zeros into the higher order bits. The result is stored on the general purpose register RD. This needs probably. In 64-bit mode, the sign extended 32-bit value is stored as a result. Good to know. Isn't that the difference between logical and arithmetic shifts? Is the sign extend? I never actually cleared that up. Like, what was it? 6502 has like a logical shift right, but then an arithmetic shift left. I don't necessarily understand that. I don't think I've ever learned that. Because like it doesn't have both. Like it has like 6502 only has an arithmetic shift left and not a logical shift left, and only an arithmetic shift right. Or sorry, only a logical shift right and not an arithmetic shift right. I mean, in our case, it tells us right here what we need to do with sign extending and everything, so I'm not going to worry about it, but just thinking about that. One of those things. Okay. So I'll call this SA to be consistent with the data sheet. Or maybe I'll add another instruction to get out SA in this case. Because the problem is they start to feel a little different, like where we're actually getting these from. But let me look at that. Movie00 is saying, shifting left should really be the same arithmetic versus logical. Wait, that might be wrong, but listen to me. And that's what I mean. Like, I actually don't know what the difference really. Kicks and Giggles says 6502's arithmetic shift is called that way because the highest bit which gets shifted out goes into the carry flag. Yeah, I forgot that did that. Most of the instructions, like it doesn't have add, it only has add with carry. Those are actually really beneficial as soon as you have numbers that are bigger than 8 bits. Because if you're doing like a shift of like a word like that's four bytes long, then you can actually just shift one after the other without having to interact with anything, and you'll get the right bits shifted in the carry. Actually, though, in that case, I could actually be wrong about that because I don't think the arithmetic shift doesn't shift the carry back into the register either. I don't think, because otherwise it would be a rotate. In a way. Maybe it doesn't, I'm wrong, but I don't think that's how it works. Been a long time since I did 6502. Long time. Where were we? Yeah. So it looks like, and I think we kind of got lucky because I definitely didn't think about this when I was writing this, or maybe I did and forgot about it. But it looks like whenever you read RS, it's always going to be the same bits in this case, or same with like RT and RD, right? Like these are consistent. We wrote these for a different instruction. It looks like they cover the same bits here. So I'm guessing SA is actually going to be the same in that sense. So I'm just going to add that here, just to help our decoding here. And that was shift left 11. That's going to be shift left 6. Cool. So now I can do this. This one's going to be really easy. Self dot right reg GPR RT, right? And the value is going to be L. Okay, dot RT. Yes, that's actually wrong here. It's RD. Yeah, shifted right by RD. Or, sorry, SA. knowing that I put on the next line anyway. And then we just write the value here. Yeah, I'm actually going to put this back. Oops. Colin, for 68K ASL, the carry bit receives the last bit shifted out of the operand. Yeah, it's the same as code too. Giggle says right, ASL arithmetic shift left will shift its 0 into bit 0. You use ASL for the least significant byte and then ROL for other bytes. ROL will shift the carry into bit 0. I actually forgot you had rotate left on 6502. Yep, you do. Yeah, that makes sense. But yeah, like in general, they designed a lot of those kind of instructions with the fact that with the use case in mind that you'd be doing multiple byte values, and use the carry to carry information between them. I guess that was like why they called it carry and stuff. But in general, I haven't actually seen I don't think Z80 does that kind of stuff. Devent MK, I can't understand shit, but hey, I would love to take your brain apart and study it. If you ever do that, I'd like to see that as well. As long as given you can put it back together again. Brains are cool. Yeah, but also, to be fair, I'm just going off on tangents. This code should actually be correct already. No exceptions. Can be raised. I think we're looking good. Oh, except the sign extent. Because we shifted it right. And then we can value as I32, right? As U64. I think that's how I was doing sign extents earlier. I think that's correct. Yeah, here I did as well. I think that's correct, because the as I32 is just going to chop the bits off, and then as it casts U64 out of I32, then it's going to know to do a sign extent. Should be good. Yeah, this needs to be as usize. Cool. We got through another instruction. I actually want to dig through my disassembly a little bit of this. Just to see if we find it. Need that little artifact there. Oh, I clicked in the wrong place again. That's the problem I have with this interface. It's a bit jank. Was it CC where we had? I had a couple specials. We had some shifts. So actually, I'm going to look for these shifts. SRL. Actually, it looks like we already found it. I think it's here. Yep. Wait. No, I don't think it's there. It could also be out of this little chunk that I copied here. Yeah, Dan Collins said you need to look at the copy code. Another one jumps to. Yeah, I do, but I just don't know exactly where that is. So I was just going to see if I could find this particular thing of instructions. And I don't want to dig too much into the PIFF there. You know what we could do? Cheeky. Okay, just dump these bytes in here. I think this is showing me the wrong Indian now. Doesn't that work? There it is. BEQZ. Dan Collins, yeah, just saying how we can get that address. But we also had to know where it was copied from in order to get the right address in ROM. Otherwise, I would just like print the value of the address that we're loading from, which I've kind of done here. I think this is actually okay just to look at the single instruction. So it looks like I have the right value here at least. Did I not do this one? Oh yeah, BQZ is going to be branch equal, right? Just with one of those. Oh yeah, I think I did branch equal likely. I don't think I did branch equal. Yeah, see, I did the likely one, not the regular one. That's why. This makes sense. Yeah, this is going to be branch equal. So where is the... There we go, branch and equal. Now what's cool... Yeah, QRAM is saying this is another pseudo-op. Yeah, I realize that. Where it's just going to be branch equal normally, and then one of the registers is going to be the 0 register. So this one's going to be nice and easy to do, just because of the way we set up these other instructions. In particular, it's going to be this right here. BEQ, and these should be equal. Just because we've already set up this branch thing. I believe that was the last session. And then this will always run the delay, whereas likely won't run the delay if it doesn't branch. Double negative. The likely instructions will only run the delay slot when you branch. Let's put it that way. Okay, that should do that. Now I get another special opcode. Probably some more shifts. I'm guessing we're deep into the CRC stuff now, because I'm just seeing a bunch of shifts and moves and branches. I'm just going to dig through the special opcodes again until I find this one. Or I could do the same thing again where I just disassemble these bytes here. That worked. This way I don't have to like dig through it in the ROM. And making sure this has the right ending. Or, yeah, that makes sense. And then we're still able to actually view it. 094025. Okay, so now I go back to our datasheet. For OR. I thought I implemented OR. Oh yeah, I implemented OR with immediate. That's the difference. That's a very, let's look for OR I, and but it's going to be next to it, so I can actually find this. Nope, not that one. This one. There we go. I'm guessing OR is going to be right before this. Bloop, there it is. Hooray for alphabetical datasheets. Some coding here. Here, actually. Yep. Logical OR operation applied between the contents of the general purpose registers. RT is executed in bit unites. The results stored in general purpose register RD. I'm guessing that this will also like not do any sign extend stuff. Oh, whoops. I did this wrong. This is a special opcode. That matters. TJS are all these opcodes of the special type. This one was. So this is wrong. Do that there. Or up here. Yeah, seems most of these like shifty ones are these instructions are shifty. Dumb joke. Yeah, it looks like these are special. Self.write reg GPR. Also, want to just double check again. Wait, really? Okay. Just that these are pointing at the same amount of bits. I know I just pointed at my screen, but I pointed with the mouse too. Like RS is always going to be from 21st bit. RT is always going to be the 16th. RT is always going to be 11th. Yeah, that's good. That makes me happy. That's satisfying. Self.read reg GPR RS. Really? I wanted that to be. Just deal with it. Deal with the line length. Getting tired of trying to make that look good on the stream. And that'll be .rd as usize value. Yeah, and we don't have to worry about sign extends here or anything here because in 32 or 64-bit that wouldn't happen. Can all be correct. I'll just read this one more time to make sure I got this right. Lots of OR between the RS and RT, and then stored in RD. Good. Yeah, and then we have another. Now I actually panic at an unrecognized physical address. Cool, so this is 048. Now I go back to our memory map. Definitely seeing this cycle, 048. These ones are the serial interface registers. And I believe that was stuff like interrupts. Said someone earlier that I'm looking up. Yeah, FPGA Nugga said that. No, wait. Yeah. More confusingly, PIFF handles SI serial stuff like EPROMs and controllers. Cool. We've already been at this for 2 hours. Let's do that stuff then. My map. Base reg. And where specifically did we write to in here? 1.8. which is this guy, the status reg. And yeah, we're loading a word. So we're reading the status reg of the serial interface. Cool. I'm going to end up modeling this as something separately from the PIFF, I think. Because I feel like doing that. Oh, cool. Java update ready. Stewie getting past my almost out of Eurozone bedtime. Laters. Cool. Glad you enjoyed the stream. Thanks for stopping by. Elfadal saying I don't understand ASL versus LSR. We both had 0 to their respective sides. He's talking about the 6502 opcodes we were talking about earlier. Frankly, I don't really understand either. I wish that I understood that. I mean, given the fact that you just like know what they do, the naming doesn't really matter that much, like from a practical sense. But I'm still curious. Yeah, so we had size status reg U32. Double check again. 1/8. Sorry, I had this wrong. Oh no, I just wrote the wrong end address. Or I wrote the end address to the start address. Cool. Kissing Eagles just said, Alfred, are you familiar with two's complement? And actually, you saying that just kind of made me... I still don't necessarily understand why the names are named that way, but it would make sense, actually, that both of them shifting 0 would be arithmetic one way and logical the other way because of two's complement. I could definitely see how that starts to make sense. Yeah, so we're only going to have to worry about reading this register for now. Writes clears, any write clears interrupts, because I guess the SI can raise some interrupts. No, we're not going to worry about that yet. We're only going to do the read. And probably just reading out 0 is going to be okay for now. Yeah. Just boilerplate. I'm guessing we'll be able to do default here. Unlike arithmetic shift, a logical shift does not preserve a number's sign bit or distinguish a number's exponent bit from its mantissa. Cool. Now we'll need to just mapping that. Kissy Giggles, thanks for the clarification. It may be easier to differentiate between how the instructions are implemented versus what they semantically mean. Arithmetic shifts semantically mean this register is sign, now multiply and divide this by power of 2. Whereas a logical shift just means there's a bunch of bits, shift them like meaningless bits. Cool, so I guess an arithmetic shift left, you still get a sign, because if you shifted left, then the next highest bit becomes the sign bit, and that's actually correct. For that value. Whereas a logical shift right is just going to stick a 0 in there because there's no sign preserved. So that probably makes sense. Cool, thanks for the clarification. Also correct me if anything I just said was wrong. But that's good to know. We're starting to see more of just like the same things when writing this code, which is generally not too bad right now. I don't know if that's particularly good, but I think it just means we've abstracted something okay. I'm gonna panic when you write the stage reg for now. L-Fade, just clarifying as he's reading stuff on Wikipedia. This is cool, I didn't know this stuff. Thanks, guys. Yeah, and of course we need to derive default from this. To get default values for all of its fields, even though it doesn't have any fields right now. Cool, so it looks like we made it through that. Now we're getting another unrecognized physical address 0460. 046014, which is going to be another one of the peripheral interface registers. In this case, peripheral interface DOM1 latency. What is the DOM1 thing? No idea what that means. Let's see if there's any information of that here. That is not a collection of characters that I've ever heard of before. Is that something specific to this system, or is that like a general hardware term I've never heard? I could just Google DOM1, but we'll see what happens. Getting a bunch of new HTML stuff to do that. Mika FCP, will you be the one to make a good 3DS emulator? What, is like Citra not good enough? Not micro. I think you can fake it. Most emulators do. Thing is, I just don't know what that means. I have no idea what the DOM1 thing is. Does this have something to do with like how the cartridge slot is read? I just don't know what this DOM is. Or I guess it's domains, but like what is domain latency, domain pulse width, domain page size, domain release? I don't know. What if I search domain? Anything in this document? Okay, so now it's saying cartridge domains. Okay, maybe these are just different regions of memory that you can read from. FPGA, it's writing the slowest possible cart ROM timings, reading the first word, which contains the actual timing parameters of the device, and then reprograms itself, the PI with them. It doesn't really matter for emulators. For example, when you access cartridges that have SRAM on there, you have to adjust the PI physical timings to access it. Okay, now that makes total sense. That makes perfect sense. Because your SRAM is going to have different access timing than your ROM, probably. So you would actually want to control the actual read and write timings over that bus. And yeah, he's saying it doesn't matter for emulators because we really don't have to worry about that. And the other thing about this kind of timing is I'm guessing that it's not actually going to really affect like clock rates in terms of like how fast can we read that memory. I think it's actually going to figure out like, yeah, where along these pulses are different lines coming high or low. Or it might be affecting clock rate, but again, I don't think that's going to be something we need to worry about. Cool, so now we at least have learned something about the cartridge domains. And the important part here is, I guess it's just, yeah, different ways you can access memory on the cartridge. So yeah, so what he was saying is it's going to write the slowest possible cart timings on there, just in case. And then it's going to read the word that describes the timing, probably. And then it's going to use that to then change the timing again before it reads anything else. That's pretty cool. That's what I'm guessing is what you just described. And that would make sense. This is the kind of stuff I actually really like learning. Where it's like, I have no idea what this is doing, but as soon as you hear like the gist of it, it just makes total sense that it would do that. You know what I mean? Dana, call on time to get some sleep later. Yeah, see you, man. I don't know if I'll go for that much longer on this project today. Let's keep going, but because actually I really want to work on some demo engine stuff. So I might switch to that later. But I'll do this first. Okay, so this is where we were. It was writing to this domain 1 device latency. And we're just not going to worry about these. Oh, I already had that open. That's cool. Base reg, sys reg. There we go. Dan Collins says stream it. Yes, I will. I don't know if I'll put that on YouTube too, but I might as well. It's not gonna hurt. And I will stream it, so at least it'll be on VOD. That doesn't hurt to record that stuff. There's certain things I don't want to record, like Stepmania and stuff, but I still kind of want to stream anyway, just to hang out. But other things where I'm actually doing programming, it makes sense. I like the idea of having like this one project where I do everything on the stream, and then just having a bunch of small other streams that I do where I'm just like, I do a little here, a little there. That's cool. But yeah, Dino Call and I will do that. I'll at least stream and have the VOD. I'll record it just in case. if I work on that later today, which I probably will. Oh, this song is so cool, by the way. It's I know you guys can't hear it and listen to it, but I'll link it directly. It's called Black and White Lies, and it's actually a demo soundtrack. It's a soundtrack for a demo of the same name by a group called One Studio Off, which is actually Fairlight and CNCD, but just with a different name. For reasons I do not know, but could probably guess, it's so that people just don't, say Fairlight demo and then love it or hate it. You get to judge it on its own if you don't have that group name associated with it. That said, stylistically, it's very obvious who did it, if you're familiar with demo scene stuff. So this gives me a couple different things that you could name this in this case. I think I'll go with the first one just because it'll match up with the names of the other ones later. Even though it's a stupidly long name. It makes me adjust all my other stuff. I think that's really good. Actually, TJS, are these values that your emulator has to pay attention to? Or was I correct that it basically has more to do with like wire-specific timings and not necessarily a clock speed? TJS, sorry I missed that. Oh, I was just asking, like, we're working on these, we're writing to the peripheral interface domain 1 register, like these things that basically describe bus timings for the different cartridge domains. Is that something that your emulator cares about, or am I basically correct in assuming that the clock speed with which you read from that bus is basically going to be the same, that this is just like wire timings? I'm just curious. And sorry if the audio is not that loud. I could probably bump up my mic. You guys should yell at me if you think I should do that. He's just saying, not right now, but it may perhaps be needed to prevent a certain ROM from printing fail. He's referring to that MGC 2011 demo, which will basically do a bunch of like hardware tests on its own first to determine if the system that's running it, be that a actual hardware system or an emulator, is correct enough to actually run the rest of the demo. And if it's not, it'll just say fail on the screen, which is kind of funny. Written by Marshall H., one of the guys in that PIFF RAM demo, and also he's on the N64 dev a lot. But yeah, TJS says, in general, nothing really uses it, so don't worry about it. Cool. I will not worry about it then. I'm going to copy this because I can't remember all these different name parts. Casey Giggles says brutal. Yeah, it's actually kind of cool that the demo does that, but not if you're running an emulator. Oops, why did I? Should be down here. I need the stage register. I like to keep things in some kind of order. Hopefully I'll get some auto-completion up in here. I just don't feel like setting it up, frankly. I guess it's pretty easy, and a couple guys have sent me like, yo, you use this package and you configure it this way, and like, I just don't feel like doing it. But it's possible to set up with Rust, as far as I know, Remix. Actually, when I stopped using autocomplete, I was surprised at how little I needed it in general. You just kind of get used to keeping that stuff in your head or looking it up. That's nice. Yeah, I'm going to make the peripheral interface actually read this. But Fadal says, yeah, I feel you. Most of the time autocomplete just dies on me. Yeah, exactly. Like, I mean, it's an awesome feature that a lot of editors have, but sometimes it's not necessary. Do this, and I think there'll be a right to this as well. I think it's okay to just print this. I don't think any games are going to hammer on that. Kissing Giggles, Adam with Rust plugins has been doing a great job for autocomplete for me. That's cool. Adam's actually getting to be a cool editor. It was so slow when I first tried it out, but they cleaned that up. I don't think I'll ever leave Emacs at this point, though. I'm stuck. My poor pinkies. Yeah. So we're doing this stuff. I should do it. It's on performance. Oh yeah. Forgot the self-references. Yeah, now we're getting to these, now it's writing the other registers. So I'll probably just hit all these in one go for now. Just because I have a feeling they're all coming. And the implementation is going to be trivial for all of them if I just ignore the values, so. Just going to fill all of them out. Oops. See, strobe, rewrite strobe pulse width. Release duration. Oops. I missed one. Price on page size. Okay. That should do it. Now for something completely different. Yeah, here we go. It wrote to all these different registers. Nice. Now, I'm guessing it's reading that something from the cartridge at this point. Cartridge domain 1 address 2. Sick. Looks like we're actually digging in the cartridge now. I think that's quite nice. Kicks and giggles, yay, new address. Yeah, this is cool. This is really cool. That's all this actually seems to give me is that it was the cartridge domain. It's cartridge domain 2 address 2, right? Cartridge domain 1 address 2. Here. Yeah, so this is the ROM header. Yep, and there you go. There's those initial timing values right at the beginning of the ROM header. Just like FPGA Nego said they would be. So it's probably going to read those and then, yeah. That's actually cool. I didn't realize the hardware would do this. It would set up the bus timings to be basically very tolerant and then read the first bus timing values and then go and change its timing. Oh, that's cool. But this is sick. This actually, I'm going to implement these really quick and then just kind of make sure that these registers get run with the correct values. And that might be a nice place to stop for this project for today. But yeah, it's cool that we're about to actually dig into the cartridge. By the way, the ROM that I've been testing with is, it's called the Fire Demo by LAC, which is a public domain ROM. And it's in that large collection. I keep mentioning this large collection of ROMs. I want to link that really quick. Let me pull up the old repo. I link it here under, yeah, so this is a README. And there's a test ROMs, and there's this Turtle's enormous public domain ROM repository. And okay, there's a ROMs folder, and in there I have the Fire Demo by LAC. So this is the ROM I'm testing with. For those of you playing along at home. Scorpion Illuminati says, Ferris stream stuff, make an emulator for the Sega Saturn. Maybe. I'm actually not that interested in that system because I don't like have any nostalgia with it. I might end up doing a SNES emulator in Rust, but I don't want to do like all the mappers and stuff and all the special chips. I did do, of course, the audio unit, but Meta one at a time, yeah. Emulator's big. Churro one, yay! Oh, this is an enormous collection of ROMs, by the way. Awesome. Yeah. Yeah, so what I'll do here is I'll do these. So I want to, in memory map, I'll start actually looking at the cartridge domain. Man, this is cool. Made good progress today. One thing I'm kind of worried about, or not worried about, curious about, it says cartridge domain 2, and then there's different addresses for the same cartridge domain. I'm wondering if that accesses the same memory or if that is actually something different. It's just 404. I think you should do it, make an emulator for some obscure system with no documentation at all. Yeah, you can find one. Kicks and Giggles says Rust emulator for Virtual Boy. Actually, I do want to do that. That's actually on my list. Because I think it'd be really fun to play those on 3D TVs. Scorpion Illuminati. Oh, you're saying supposedly there aren't any good emulators that run at 100% speed for the Sega Saturn. Is there a stage on the FDS? I don't know what the FDS is. As for making an emulator with like no documentation on it, that would require that I actually get a system that I can test on. I actually would be fairly interested in doing that. Famicom, I think, won't be exciting enough, frankly. Oh yeah, just coming with the Famicom disk system. Yeah, actually, that would be fun if I had one. Exciting for me, it says. Yeah, no, man, as long as you stream it, yeah, of course. Actually, I would love to do that too, like have a system like that and just reverse engineer. Actually, I bought this. This is like a shitty kids computer thing. It's a little VTech. I bought this at a thrift shop for like $2 because me and my dad go thrift store shopping together. There we go. Woo. Speaking, sorry, $2.80, so $3. And I want to see it has a full color screen on it. Oh, this thing is awesome. It has a full color screen. Let me fire it up. Runs like a champ. Has audio. And I went in and opened this up, and I found a EEPROM, like a little flash memory. And other than that, I don't really know anything about this. So maybe I'll have to do some reversing on this, but we'll see. Because I'm guessing the EEPROM is going to be just save memory and not, because I did find a datasheet at one point, I forgot what it was, but I think it's just going to be used for save memory and not program memory. So it's, who knows what I could do. But it would be cool to do a demo on this because it has all the hardware, but like, I don't know. If we're looking for something obscure that I might reverse on stream, this might be it. Graphene Punk, have you read Hacking the Xbox by Andrew Hong? Yeah, I love like everything that Andrew Hong is Bunny, by the way. I love everything that guy does. That's an awesome book. Scorpion Illuminati, I don't think there is an FDS system emulator in the wild at all. Yeah, I don't know. I haven't looked. Jura1, you were thrifting. Yeah. Man, what a beast. Oh, hey, Kuzma. Don't know about N64. Good to see you, by the way. But at least on GBA, the same cartridge memory is mirrored with different weight states. Ah, that might be this as well. Jura1, that thing is pro as heck. Get a demo on there. Yeah, it's very tempting. The first step would be to try and pull that boot ROM. And I actually have hardware to do that because I think I mentioned before that I'm trying to resurrect these Chromebooks. So I have like this clip thing with the Raspberry Pi and like voltage level converters to actually get at that. So I actually have the hardware to try and pull the boot ROM. But yeah, just need to dig into it, I guess. And again, or sorry, I don't actually know if it's a boot ROM. I mean to pull the memory from the EEPROM, which is probably just save memory. FPGA Nugget, I wonder if it's a Sun Plus chipset. I have no idea. I have no idea what's in there. It's an epoxy blob. But I could contact that McMaster guy. He'd probably be interested in pulling that off. Is N64 DD obscure enough for you to make an emulator for it? Says Scorpion Illuminati. I don't I don't think obscurity is really what I'm looking for, unless like, because someone else brought that up. Man, I make it run Linux. No, I don't want to do that. I want to do a demo on it. Yeah, I was actually going to say that TJS and Not Mike Ryan are both basically plugging that N64 has 64DD support. I don't know how far along it is. Have to ask them, but they are at least definitely working on that, and they've gotten pretty far. Graphene Punk had Linux on his PS2. That's pretty cool. I don't think this little hardware could really run Linux either. TJ asked if you're linking some of that 64DD stuff. If you message it to me or DM me, I can share that link. Your fancy kid laptop, yeah. I just think it'd be really funny to reverse something like that and just get code running on it. $3 for a project. I'll probably end up making a demo for this before I do that, though. This is a FPGA. TJ, so I don't know how to DM, but I'll try. Honestly, I don't know either. I know how to read them. Not Mike Ryan, 1064 boots several DD games. All of the games that don't boot are likely due to CPU and timing bugs. That's really cool. It's awesome. And Twitch's link hiding whatever is just awful. Scorpion Illuminati, thanks for the host. I think that's the first host I've ever had, so that's actually really cool. TJS forums.1064.com/deleted link ? Oh man. Oh, you're also saying that actually guys on IRC can see links. I didn't actually know that you could hook up IRC to Twitch chat. That's cool. Scorpion Illuminati, will you please do a Hyperscan emulator? I don't know what a Hyperscan is. Or what you mean by that. But if it's some badass retro thing, which it might be with a name like Hyperscan, then I want to see that. 01. Twitch's IRC is so wide open that you can even pass non-setters up to people and crash their clients. It's like the 90s all over again. Sure one, let's see it. Yeah, let's not. At least don't shut down my stream. Scorpion Illuminati, link permission, please. I don't think I can do... I think if I add link permission, I have to do it for all links. And I'm not necessarily comfortable for doing that. Or comfortable doing that, because, like... Yeah. I'm just not comfortable doing that. Not Mike Ryan. Hey, Ferris, beers in Mountain View. We should do that, like... I don't know if you're talking about today, but I want to do it. Oh, it is tonight. It says TJS. Yeah, I might meet you guys. That might be fun. I really want to code demo stuff. I'll probably meet up with you guys later. Let me know when. Hit me up on something. TJ said, not Mike Ryan. Not Mike Ryan, bring your laptop to Tide House. I'll do it. Don't tempt me. Guys for links, if you just like DM them to me, if you really want to share them, then I can at least screen them that way, and I'm comfortable doing that. So. Not Mike Ryan, bring your laptop tonight. We can surf the dark web on it. That's awesome. 5 games were released for the Hyperscan. Okay, I'm Googling Hyperscan right now. Because here's what I love about the Hyperscan is the name. Here, I'll share the Wikipedia link, guys. Hyperscan is a video game console from Mattel. It used RFID along with traditional video game technology. It's marketed toward boys between the age of 5 and 9 who are not ready for high-end video games in terms of maturity or expense. But the included game was rated T by the ESRB, and the remaining titles were E10+. 2006, man, I've never heard of this. Oh, dude. The system was continued in 2007 due to poor console game and card pack sales. It is featured as one of the 10 worst systems ever by PC World magazine. Little Sun Plus, SoC. UART I2C SPI? Why would it have that? Composite video output. SoC supports TFT but doesn't use it. 16 megs of RAM, 640 native resolution, one USB port. And I'm guessing this is going to have like a rasterizer and stuff. Yeah, it looks like there has been some homebrew on it. So has no one done an emulator for this? I don't actually know what TFT stands for, but as far as I understand, it's like a digital display protocol, like a standard. But I actually would be genuinely interested in in getting a hold of one of these and doing an emulator for it. If someone can contact me later and either get me one of these or send me a link to somewhere where I can, and also prove that there's not an existing emulator, then I think that'd be fun. Jura1, yo, I'm not saying this is a good idea, but there is a Hyperscan on eBay for 15 bucks. If you sent me the link, I would look at it. Scorpion Illuminati actually has stuff for it. Okay, you guys need to email me or something. We're getting really distracted here, but I'm just looking at links and stuff. Yeah, Scorpion Illuminati sent me an Angry Video Game Nerd episode on the Hyperscan. I don't think I can like just rebroadcast someone else's stuff, but there's the link for it if you guys want to watch it. Man, that thing looks so shitty, and I love it. Oh, yeah, and TJS also sent me a link for the Linux on N64. I want to share that as well. Yeah, but Hyperscan, if people are doing homebrew on it, does that mean it has like some documentation available? I'm curious. Okay, I'm getting way too distracted by this Hyperscan stuff. Super Illuminati says, no, I was part of the initial effort. We only had a Hello World demo running and nothing else. It's me and two other people. That's really cool, man. I'd actually love to see more of that stuff. I think that's... I love that. It just sounds like a stupid, crazy system. It's cool. Okay, I want to do this memory mapping now. Yeah, from what I can tell here, it looks like this is the same. Or, wait a minute. I think it just has these two domains, and then these different addresses are not actually like different on the system. I think it's just showing me that these, it's just giving me two memory maps for the same location. I think that's what that was. Script Illuminati, yeah, it was him, PP Chasm, and Wiki Columbus. And I seriously would love to see that stuff. If you could send me that stuff, that'd be cool. Just to look at. I mean, I don't. I want to finish this emulator first, I think, but I would totally be down for doing that as one of my next emulators, just because I love that it's just some obscure, shitty hardware. I think that'd be really fun. What's this here? Not at all any Emacs packages you personally recommend. Not off the top of my head. I have my .emacs file publicly available now. I'll pull it up. Let's look at that. There you go. Scorpion Illuminati saying basically it was a cross between video game console or cross between video games and Yu-Gi-Oh! Master cards. Basically what JR said. Amiibo, the console before Amiibo was a thing. I've never heard of the Amiibo thing. Oh yeah, now I get what you're saying. Tip the Amiibos are cards, not figurines. See what I mean? you watch the AVGN episode, it'll make everything clear. I bookmarked it. I'll make sure to watch it when I'm done with this. I just really want to get through this memory mapping now. I played MX NAND mode. Yeah, I do have NAND mode. I forgot. I set that up a long time ago. I never use it. Turn it on. It's literally just this. Like my scroll is a NAND cat. That's all it is. Apparently it can move and stuff too. I thought that was funny. Totally forgot that was in there actually. I'm gonna call this dumb one. Make it not super long. Oops. How long is this chunk of memory? See that up here? Somewhat adder one actually. So I'm gonna have to fix all my limits anyway. Whoops. Someone actually told me like there's code to do this to actually like align everything for Emacs, but what else? Yeah, I knew that was going to be one more. No worries. Pretty sure this is why the Rust style guidelines tell you shouldn't align stuff like this. But I just don't in mind right now. Looks like that's the length. Scorpion Illuminati. I'm serious. If you end up doing Hyperscan, let me know if I'll even help as much as I can. Dude, I really appreciate it. I'm genuinely thinking about it now. It's awesome. FPGA Nugget, don't commit to too many projects, you'll be me. Man, if you see my GitHub, I do commit to too many projects. That is already a problem. But yeah, Scorpion Illuminati, if I ever look into Hyperscan, which I probably will, I would definitely hit you up for that. That's awesome. Thanks. Yeah. Wait, why did I call these SP? I just like copy something for that? Ah. Fix my limits again. Make sure this is correct. I think it is. is this where we're reading? No, we're reading from the second address, actually. So I'm actually just going to change these and just worry about that for now. There's FBF. I think that's correct. Or actually, that's definitely not correct. Yeah, that's correct. There we go. Lafayette says one package I recommend you use Helm. I have heard of it. I haven't really tried it out though. But I should. Stays. Yeah, okay. A cool part about this actually is that both of those address ranges were contiguous. And we can just actually do this. Cart domain 1 can be one of these. Because the thing that's actually mapping those, I can just map both of those to these because they're going to be read from the same memory the same way. Well, that's pretty cool. Cool. So this will actually bubble up all the way to the top. And I'll just store this somewhere in here. I might also name this RD-RAM. Because we haven't touched any of that, have we? I don't even think it's being used yet. Good. Can't write to those. Normal hardware wouldn't complain. It just wouldn't actually do the write. Probably. Oh, it looks like we got it. It looks like it wrote this stuff. So now what I'm going to do is I just want to open up the ROM itself and just go ahead and look and see if those values match. Because there's a couple things already where I'm like, wait a minute. And let me explain why in a sec. Oh yeah, that's cool. It's shifting out values here to write the different registers. That's what it looks like, at least. It's strange that this only got 40 here. Show a color here. Hello. First word is this 80 thing, so it looks correct. Or yeah, I guess you jumped ahead of me and looked at the ROM. I want to open it myself. And then yeah, we're fine. And then this was the first word. Hit red. Where did it get this hex 40? Oh yeah, out of that first part, yeah. It's 40, and then it reads 12 to this, 3-7. The last one looks weird though. It looks like it should have just ended with hex 80. Right? Because like the way I understand this is it's writing to those registers. And each of those registers were 4 bytes long. FPGA says the actual hardware registers are variable bit widths. I guess that can make sense. So maybe it is correct. I just want to look at this. Where was this? Where were these addresses again? That's right there. It's the advantage of naming these ways. Okay, we get these here. 7 out of 0. So these are those bytes from each one. Here's only three of those bytes. 3 of those bits. And then here, the release duration was only 1 of those bits. So it actually that could make sense. Actually, that makes perfect sense then. If it was just shifting it a little bit for those last couple. Which is really sick. That means we've actually read some cartridge ROM and use it to write some registers. That is sick. Just really quick, I want to look at we get another unrecognized physical address. I just want to look at this 0410 just to see where we're at. But I think I'll cut it off here. Those are these guys. What's the DP? DPC. Okay, busy team then. Spam. Apparently, I'm just looking through. I just searched around. I got this N64.inc from Peter Lemon. It's just DPS, or sorry, DPC, which is DP command, which is DPC, but I still don't know what this DP is. Oh, of course, yeah, DP is RDP, which is the display processor. Yeah, gotcha, that makes sense, of course. I don't know why I wasn't thinking that. Just like the SP of the signal processor. Obviously, cool. Okay, so that's awesome, actually, that we're now, yeah, started to read some cartridge stuff, set some bus timings. And then it looks like we're looking at the display processor already. Probably just reading some more status from that. Yeah, load word. Cool. So I think this is actually a great place to stop. But this is awesome. Yeah, this was a good little day. This was a good session. Oh, more PIFF. More PIFF progress. And I do not remember how to add tags in Git. I'm so bad at remembering that stuff. This is the kind of things I look up all the time. You have to add the tag and then push it as well. By the way, guys, I'm basically done. So if you guys have any questions, I usually end with that. Fire away. Oh, cool. I just specify get tag. And I think the convention I was using for this and episode 007. Good. Kicks and Giggles wins the next stream. I'm not entirely sure. I'm probably going to actually, I'll take a little break, and then I'll actually probably hop back on. And instead of working on this project, I have some demo scene stuff that I want to work on. So I might stream that just to hang out. That'll be later today if that happens. In terms of this stuff, sometime this week is the best I can say right now because I don't really know what my week looks like. But I would love to get to the point where I'm doing, 3 of these a week. So, yeah, hopefully this week. Next Saturday at the latest. Anything else? Also, thank you guys for the almost 250 stars on this repo. That is a lot higher than all my other projects. So that's really cool. I have one that's 15, but still, it's pretty rad. And of course my work stuff, but that's a bit different. Kicks and giggles, whelp, thanks for streaming, man. No problem, thanks for watching. I think this is really fun. It's tiring. Like when I stream my demo stuff, I probably won't be like talking or interacting as much. I'll just be working on stuff, but yeah, it's fun. And I'll also have this on, this will be on VOD on Twitch right away, and I'll start uploading it to YouTube. I actually didn't forget to start recording it this time, so I will actually have 1080p video for YouTube this time. It's really cool. Yep. Anything else? Nope, looks like that's it. So, cool. Thanks again, guys, for watching. Again, I'll have this up on YouTube right away, and I'll spam Reddit and everything with that, and also my Twitter. So check that out if you guys haven't yet. Also, I do plan to, one of these days, actually do like proper branding for all my pages and link backs and everything. So if you're ever missing a link, then that should be easier to find later. But yeah, thanks, guys, for watching. Gizmo, thanks for the stream. Welcome, man. Yeah, I guess that's everything. Cool. I will see you guys next time then.